This is 2024 paper 2 question 2. We're given some information here and we're told that the expected value of winnings taking cost into account is €0. Work out the value of x. So this is a little bit tricky, but the way that we'll just start it off as normal. So we can just multiply the probabilities by the prizes. So we'll have 0.3 times nothing plus 0.4 times 2 plus 0.28 times x minus 10. And then we'll have plus 0.02 times x. So this is kind of like figuring out what the average winnings is going to be. And we're told that the expected value of the winnings taking cost into account is €0. So that basically means that taking the cost into account, you're not going to win anything. But you're not going to lose any money either. So if it costs €10 to play the game, well, that means that what you should win should also be equal to €10. Okay, so make sure you don't let it equal to 0, because you're basically expected to win €10 because you pay €10. You're expected to win €10, so the game is fair. I think you'd run into problems anyway if you let this equal to 0, because the only way that this whole thing could be equal to 0 is if there was a 100% probability that you'd win nothing, so you'd quickly run into problems. Anyways, we can multiply this out, so we'll get 0 plus, and we'll have 0.8 plus 0.28x minus 2.8, so we'll have plus 0.02x, it will be equal to 10. We can combine the like terms, so we'll get 0.3x on this side, and then bring the other stuff to the other side, we'll get 12, and then we can just divide by 0.3, well, that's the same as 3 over 10, if you want to do it in your head. 3 over 10x is equal to 12, so that means that 3x is equal to 120, that means that x is equal to 40, and does it say x euros, or does it just say x? Okay, well, it says that these prizes are in euros, so we don't have to say 40 euros, because this number here is already in euros, so we can just say x equals 40. Then we're told that A and B are mutually exclusive events. We're told the probability of A, probability of B. What's the value of the following? So mutually exclusive literally just means that they can't happen at the same time. So if you think of it in terms of a Venn diagram, if we have A and we have B over here, well, basically it means that they both can't happen at the same time, so this intersection here is going to be empty. So if the intersection is empty, that means that this part must be 0.1, and this part must be 0.4. So the probability of A and B both happening is 0, because it's not possible. That's what mutually exclusive means. And the probability of A or B happening is 0.5, because you can see when we take the union of the two Venn diagrams, that's what we'll get. Then we're told about two other events. We're told to find the maximum value of the probability of C union D complement happening. So basically that means the probability of everything not in C union D happening. So I'll draw a diagram, it'll help to understand. So in this, basically C union D is everything inside of the two circles. So this is all C union D. And then complement just means the opposite. So the complement of C union D is just going to be everything outside of C and D. So basically it's going to be whatever number is in the box. You know, we write a number over here, 0.04 or whatever. It's going to be the probability of that happening. So basically, we need to maximize that. So we don't know what the intersection is going to be. So I'd probably just call it x or something, because we don't know what it's going to be. So then the probability of C happening will be 0.5 minus x. Why is that? Because when you add 0.5 minus x and you add it to x, you get 0.5, and that's the probability of C happening, so that makes sense. And then we'll do the same for D. So we'll have 0.7 minus x here. And again, what's the probability of D happening? Well, it's going to be this entire circle, so it's x plus 0.7 minus x. So it all makes sense. And then we're going to have to figure out what the number out here is as well. So I'll do for simplicity, I'm just going to call the thing outside y. And we're basically trying to find the maximum value of y. So we know that the total probability always has to be equal to 1. So we can just add up everything in this diagram, and we know it'll be equal to 1. So we'll have 0.5 minus x plus 0.7 minus x plus y will have to be equal to 1. That's just all the probabilities added together. And then what we're going to get is we'll get 1.2 minus x plus y will be equal to 1. And then what we can get y by itself. So we can say that y will be equal to minus 0.2 plus x. So if we want to get the biggest possible value for y, clearly we need x to be as big as possible. So let's go back to our diagram. What's the biggest value that x could be? Well, you might think, oh, it's 1. But then this probability here would be negative, and that doesn't really make sense. So the biggest value for x we can have is 0.5, because then this will be equal to 0, and this will be equal to 0.2. And then there's no problems. But if this is any bigger than 0.5, we run into problems with the negative probability over here. So we could say that the max value of x, will be equal to 0.5. So therefore, y will be equal to minus 0.2 plus 0.5, which is equal to 0.3. And remember, y is the number outside of C and D, so that's basically the probability of the complement. So that's y is what we're looking for our final answer. Then we're told E is the event that it will be raining tomorrow, F is the event that I will wear a coat going outside tomorrow morning. Why is it not reasonable to say that they're independent? Well, the reason is because one depends on the other. The probability of me wearing a coat when I'm going outside, that depends on whether it rains or not. So if it rains, that affects this probability. So the events aren't independent. F clearly depends on E. So you just write something like that. For example, this is what the marking scheme had. And yeah, that's the whole question.